Alright, so this is Mathletics Competition 1, Individual Round 2012-2013 with calculators. Alright, so here we go. Anya, oh that's very nice. My daughter is now putting a laser on my screen. Of course you can't see that at home. Alright, so a gram of fat contains 9 calories and 1 gram of carbohydrate contains 4 calories. A 13-year-old boy should consume 2,200 calories each day. How many more grams could a 13-year-old boy eat if all of his intake were from carbohydrates and proteins instead of fat? Express your answer to the nearest whole number. So I'm going to make the assumption that we are going to get all of our calories from fat or all of our calories from carbohydrate and protein, which I realize is completely unrealistic. So if I have 2,200 calories and 1 gram of protein is 9 calories, so that means I can eat 244.4 repeating grams of fat. Then I have the 2,200 calories divided by the 4 calories per gram, and so that's 550. So I'm guessing I'm just going to subtract these two, right? And it says to the nearest whole number, so here we go. So if I go 550 minus 244.4, I get 305.6, round that to the nearest whole number, and that's 306. And obviously that would be grams, but don't put the units. All right. Miss Franklin. Missy Franklin in the 2012 Summer Olympics finished the 100-meter backstroke with a time of 58.3. The 8th place finisher finished in a time of 1.05. If the top 8 finishers were equally spaced, what was the finishing time of the 5th place finisher? So I'm going to make a little chart. First, second, third, fourth, fifth. The above is in accordance with Educational Decree number 26, signed to Boris Jane Umbridge, High Inquisitor. All right. This latest decree had been the subject of a great number of jokes among the students. Let's scoot this over. All right. 7, 8. All right. So in first place we have D8.33, and then 8th place finisher was 1.00.5. So the difference in these times, is first thing I'm going to look for. We have 60 seconds, 0.5, minus the 58.33. and that is 2.17. So the difference here is 2.17. Now that difference is going to have to go for 1, 2, 3, 4, 5, 6. So I'm going to divide this by 6. All right, so here we go. We're going to add that over and over again until we get to the 5th place. So I'm going to write this here. 3, 6, 1, 6, 6, 7. So we have 58.33 plus 0.361667 equals, so it's 58.69 plus 0.361667. Oh well, that's not going to matter much. Oh, come on. So 58.69 6, 9. Oh shoot. Sorry. Starting over again. 0.33 plus. Oh shoot. 0.361667. Okay. So then I'm going to add 0.36. Okay, you know where to go. 59.05 plus 0.36167. So that's 54.42 plus 0.36167. 59.78 plus 0.36167. So that's 60.14, and hopefully, if this worked out, point plus 0.36167. And it worked! Look at that. So here's our answer. Obviously, it did a little extra, but whatever. Okay. And yeah, there we go. Hey, game. So, moving on to the next one, 3 and 4. Well, what's up? What's up, guys? Are you sure?
What?
Are you sure?
Yeah.
Okay. All right. So here we go. The following is a box plot of the number of votes for President of the United States that each state has in the Electoral College. The number of votes for each state is based on the population. That includes all 50 states in the District of Columbia. Use the box plot to determine how many states have more than 12 votes in the Electoral College. Well, so I know that there are from here to here, I know that is going to be 25% of the data. So, what is 25%? Or what's the top 25%? 37. Oh, so that is, luckily, that is also so that's 12.5, right? So how many have more than this 12? Right here. 12. Simple. Because 12 is 25% of the data, essentially. And this is showing the median of the median, because here's the median. And here's the median of the median right there. That was quick. All right, the BMI can be calculated. Can be calculated by the following formula. Oh, that's fun. Where h is the height in inches and w is the weight in pounds. Determine the BMI for a 5'6" tall person who weighs 120 pounds. Express your answer as a decimal to the nearest tenth. So obviously, the height is in inches, so 5 feet. 5 times 12 is 60. 60 so 66 inches. So we have 66 inches divided by, oh, sorry, your weight first. So that's 120 times 66 squared times 706. So here we go. We have 120 divided by 66 divided by 66, and then we multiply it by 706, and we get 19.44, and it says the nearest tenth, so it says 19.44. Simple. All right, next problem. All right, back here. Find the slope of the given, oh my goodness, find the slope. So we should be able to find the slope, no problem. So y is equal to mx plus b, where m is slope, b is y-intercept. So the y-intercept is right here. That's just 1, 2, 3. So we have y is equal to mx plus 3, and then simple. Slope is rise over run. And so the rise is -2 because it goes down 2. The run is 1, 2, 3. So my equation is y is equal to -2 over 3x plus 3. Now my only thing here is it says find the slope. So the slope is this piece right here. It's only the coefficient. It is not the x. Don't write the x. It's only -2 over 3. Now, when there is no scale here or here, it is implied that each square is worth 1. If this had a scale, you'd have to use the scale to determine your rise and your run, not just count lines. And finally, the last one. The sequence begins, oh my goodness, 1, 3, 25, 27, 49, hey pretty, and consists of all the odd numbered square and cubes of positive integers written in sequence ascending order. Numbers that are both squares and cubes, such as 1, are written only once. What is the 16th number in the sequence? All right, so here's what I'm going to do. I'm going to write the squares. 1, 2 times 2 is 4. No, not so good. 3 times 3 is 9. 5 times 5 is 25. It's only odds multiplied together. 7 times 7 is 49. 9 times 9 is 81. 11 times 11 is 121. 13 times 13 is 169. So that's only 1, 2, 3, 4, 5, 6, 7. We need to go a lot more. So then I'm going to have 15 times 15, which is 225. 17 times 17 is 289. 21 times 21 is, I think it's 441. This is when I'm going to start forgetting. Yes, Anya? Yeah. 23 times 23. Anya, you're just going to have to wait. Let's do one more. Oh, that's 625. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's start putting in some cubes, shall we? So my cubes, 1 cubed is 1. 3 cubed is, well, because 2 cubed is 8, so that's going to be an even. So 3 cubed is 27, which should happen here. And personally, if I were doing this with a graphing calculator, I'd write the equations y equals x squared and y equals x cubed. And I would make my tables and just count off of the table. That's the easiest way to do it with a graphing calculator. But I don't have one of those on this, so I'll keep doing this. So 5 cubed is 125. That happens right here. So 7 cubed, I don't know. That's 343, and then 9 times 9 times 9. So that's 729. So now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right. So I'm going to keep going, 15, including this one. So I'm going to keep going with my squares. So that this squared here is 15 times. Sorry, is 25 times 25, so 27 squared is 729. Oh, well, I need to keep going. So 19 squared is, I'm sorry, 19, I'm starting to lose track. So I have 25, so I'm on 29 squared. So it's 8. Let's do this in red. So I have 8 41. So then 31 squared is 9, 61. So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And I'm being asked to find the 16th, right? 16th number. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. However, the answer has 625. So which one have I forgotten? So this is 1 squared, 3 squared, 5 squared, 7 squared. My board doesn't work all the time. 9 squared, 11 squared. This one here is 13 squared, 15 squared, 17 squared. I forgot 19 squared. That's what I forgot. Because this is 21 squared. So 19 squared is 361. I forgot to write that down. I remember doing it. So then that would put 629 or 625 as the last one. So that is the 16th one. But again, I would yeah, it's 625. But again, I would use the graphing calculator and do that y equals x squared and y equals x to the third in the graphing calculator table and just count using that. That'd be easier.